Persistent objects in Hibernate. Now we are focusing on persistent objects. A persistent instance has a representation in the database and an identifier value. It might just have been saved or loaded. However, it is by definition in the scope of a session. Hibernate will detect any changes made to an object in persistent state and synchronize the state with the database when the unit of work completes. Developers do not execute manual update statements or delete statements when an object should be made transient. Here you can see Hibernate life cycle. Here we will talk about Hibernate life cycle, or in other words, we can say that we can talk about the life cycle of the mapped instances of the entity object classes in Hibernate. In Hibernate, we can either create a new object of an entity and store it into the database, or we can fetch the existing data of an entity from the database. This entity is connected with the life cycle, and each object of entity passes through the various stages of the life cycle. There are mainly 4 states of the Hibernate life cycle: transient state, persistent state, detached state, removed state. The transient state is the first state of an entity object. When we instantiate an object of Pojo class using the new operator, then the object is in the transient state. This object is not connected with any Hibernate session. As it is not connected to any Hibernate session, so this state is not connected to any database table. So if we make any changes in the data of the Pojo class, then the database table is not altered. Transient objects are independent of Hibernate and they exist in the heap memory. There are 2 layouts in which transient state will occur as follows. 1. When objects are generated by an application but are not connected to any session. 2. The objects are generated by a closed session. Persistent state. Once an object is connected with the Hibernate session, then the object moves into the persistent state. So there are 2 ways to convert the transient state to the persistent state. 1. Using Hibernate session, save the entity object into the database table. 2. Using the Hibernate session, load the entity object into the database table. Following are the methods given for the persistent state. Session.persist, session.save, session dot save or update, session dot merge, session dot lock. Detached state. For converting an object from persistent state to detached state, we either have to close the session or we have to clear its cache. As the session is closed here or the cache is cleared, then any changes made to the data will not affect the database table. Whenever needed, the detached object can be reconnected to a new Hibernate session. To reconnect the detached object to a new Hibernate session, we will use following methods as follows: merge, update, load, refresh, save, following are the methods used for the detached state: session dot detach, session dot evict, session dot clear, session dot close. Removed state. In Hibernate lifecycle, it is last state. The removed state when the entity object is deleted from the database, then the entity object is known to be in the removed state. It is done by calling delete operation. As the entity object is in the removed state, if any change will be done in the data will not affect the database table. Note, to make a removed entity object, we will call session.delete method. Here you can see a new instance of entities passed to transient state. Garbage is passed from transient state. Transient state is connected to persistent state. Save, persist, and save or update and update methods are passed from transient state to persistent state. Get and load methods are passed to transient state. Transient state is connected to removed state. Delete method is passed from transient state to removed state, and removed state is there. Garbage is from removed state, and transient state interacts with detached state. Detach, close, clear, and evict methods are passed from transient state to detached state. Save or update, merge, and lock methods are from detached state to persistent state. Garbage is from detached state. Here you can see converting transient state to persistent state. Here you can see using the Hibernate session, the save entity object into the database table. Here you can see using the Hibernate session, load entity object into the database table. Here transient state is connected to persistent state, save persist, save update, and update methods are from transient state to persistent state. And here database is connected to persistent state. Get and load methods are from database to persistent state. Here you can see persistent objects, persistent or managed. Persistent objects are maintained by Hibernate. Persistent entities exist in the database and Hibernate's persistent context track all the changes done on the persistent entities by the client code. Persistent entity is mapped to a specific database row. Identified by the ID field. Hibernate's current running session is responsible for tracking all changes done to the managed entity and propagating these changes to a database. We can get persistent entity in either of two ways. Load the entity using get or load method. Persist the transient or detached entity using persist, save, update or save or update methods. Here client interacts with Pojo. Pojo interacts with session interacts with database. Here you can see database interacts with the Pojo table here. As an example, we can consider this code segment. Newly instantiated instances of a persistent classes are considered transient by Hibernate. We can make Hibernate instance persistent by associating it with the session. If cat has a generated identifier, the identifier is generated and assigned to the cat when save is called. If cat has an assigned identifier or composite key, the identifier should be assigned to the cat instance before calling save. You can also use persist instead of save with the semantic defined in the EGB3 early draft. Persist method makes a transient instance persistent. However, it does not guarantee that identifier value will be assigned to the persist instance immediately. The assignment might happen at flush time. Persist method also guaranteed that it will not execute an insert statement if it is called outside the transaction boundaries. This is useful in long-running conversations with an extended session persistent context. Save does guarantee to return an identifier. If an insert has to be executed to get the identifier, for example identity generator, not sequence, This insert happens immediately, no matter if you are inside or outside of an transaction. This is problematic in a long-running conversation with an extended session persistence context. Here you can see a save object, persist. Here you can see a save method, persist the given transient instant, first assigning a generated identifier or using the current value of the identifier property if the assigned generator is used. This operation cascades to associated instances if the association is mapped with cascade equal save update. This method is in org.hibernate.session interface. Here you can see an example of mapping. A table lets you to define the table entity will be persisted into. If undefined, the table name is the unqualified class name of the entity. You can also optionally define the catalog, the schema, as well as unique constraints on the table. The constraints name is optional, generated if left undefined. The column names corresponding the column names composing the constraint correspond to column names as defined before the Hibernate naming strategy is applied. And you can see here column names. Here you can see an example of mapping in file hbm.xml. Now we are considering declare getters and setters for persistent attributes in entity types in domain model. The Jakarta persistence specification requires this, otherwise the model would prevent accessing the entity persistent state fields directly from outside the entity itself. Although Hibernate does not require it, it is recommended to follow the Java Bean conventions and define getters and setters for entity persistent attributes. Nevertheless, you can still tell Hibernate to directly access the entity fields. Attributes, whether fields or getters or setters, need not to be declared public. Hibernate can deal with attributes declared with the public protected package or private visibility. Again, if wanting to use runtime proxy generation for lazy loading, the getter or setter should grant access to at least package visibility. Now we are considering manage or persistent in persistence context. The entity has an associated identifier and is associated with the persistence context. It may or may not physically exist in the database yet. Now we are considering accessing Hibernate APIs from Jakarta persistence. uh, uh, um, the Jakarta persistence defined an incredibly useful method to allow applications access to APIs uh, of underlying provider. Um, Now we are considering lazy attribute loading in bytecode enhancement. Here you can see at lazy group example. Annotation type lazy group specifies the fetch group for a persistent attribute of an entity class. This annotation has no effect unless bytecode enhancement is used and field level lazy fetching is enabled. This is in the package org.hibernate.annotations. Think of this as partial loading support. Essentially, you can tell Hibernate that only parts of an entity should be loaded upon fetching from the database, and when other parts should be loaded as well. Note that this is very much different from proxy-based idea uh, of lazy loading, which is entity-centric, where the entity's state is loaded at once as needed. With bytecode enhancement, individual attributes or group of attributes are loaded as needed. Lazy attributes can be designated to be loaded together, and this is called a lazy group. By default, all singular attributes are part of a single group, meaning that when one lazy singular attribute is accessed, all lazy singular attributes are loaded. Lazy plural attributes by default are each lazy group themselves. This behavior is explicitly controllable through the at org.hibernate.annotation.lazy group annotation. In this example, we have two lazy attributes. We have the account payable xref id and image, each part of a different fetch group. Which means that accessing account payable xref id will not force the loading of image attribute, vice versa. As hopefully temporary legacy hold over, it is currently required that all lazy singular associations many to one and one to one also include at lazy to one lazy to one option dot no proxy. The plan is to relax that requirement later. Getters and setters are omitted for the brevity. Now we are considering making entities persistent. Here making an entity persistent with Hibernate API. The method void persist object make a transient instance persistent and mark it for later insertion in the database. This operation cascades to associated instances if the association is mapped with cascade type dot persist. This is in the interface session and in the package org.hibernate. Once we have created a new entity instance using standard new operator, it is in new state. You can make it persistent by associating it to either an org.hibernate.session or a jakarta.persistent.entity manager. org.hibernate.session also has a method named persist, which follows the exact semantics defined in the Jakarta persistent specification for the persist method. It is this org.hibernate.session method to which the hibernate jakarta.persistence.entity manager implementation delegates. If the domestic cat entity type has generated an identifier, the value is associated with the instance when the save or persist is called. If the identifier is not automatically generated, the manually assigned usually natural key value has to be set on the instance before the save or persist methods are called. Now we are considering deleting, removing entities, obtaining deleting an entity with Hibernate API. The method void remove object mark a persistent instance associated with this session for removal from the underlying database. This operation cascades to associate instances if the association is mapped cascade type dot remove. This is in the interface session and which is in the package org.hibernate. Entities can also be deleted. This is deleting an entity with Hibernate API, and this is deleting an entity with Jakarta persistence. Hibernate itself can handle deleting entities in detached state. Jakarta persistence, however, disallow this behavior. Implementation here is that entity instance passed to the Hibernate org.hibernate.session delete method can be either in managed or detached state, while entity instance passed to remove on jakarta.persistence.entity manager must be in the managed state. Here you can see we are considering obtain an entity reference without initializing its data. Obtaining an entity reference obtaining an entity reference without initializing its data with Hibernate API here. The method tt get reference class t entity type object id return a reference to the persistent instance with the given class and identifier, making the assumption that the instance is still persistent in the database. This method never results in access to the underlying data store and thus might return a proxy that is initialized on demand when non-identifier method is accessed. This is in the package, this is in the interface session and which is in the package org.hibernate. Sometimes referred to as lazy loading, the ability to obtain a reference to an entity without having to load its data is hugely important. The most common case being the need to create an association between an entity and another existing entity. Here you can see the obtaining an entity reference uh, without initializing its data with Jakarta persistence. Here obtaining an entity reference without initializing its data with Hibernate. These examples work on the assumption that the entity is defined to allow lazy loading, generally through use of runtime proxies. In both cases, an exception will be thrown later if a given entity does not refer to actual database state when the application attempts to use returns proxy in any way that requires access to its data. Unless the entity class is declared final, the proxy extends the entity class. If the entity class is final, the proxy will implement an interface instead. Now we are considering obtaining an entity with its data initialized. Here obtaining an entity reference with its data initialized with Hibernate API. The method get class T entity type object ID returns the persistent instance of the given entity class with a given identifier, or null if there is no such persistent instance. If the instance is already associated with the session, the return that instance. This method never returns an uninitialized instance. This is in the interface session, which is in the package org.hibernate. Obtaining an entity reference with its data initialized with Jakarta persistence. Here obtaining an entity reference with its data initialized with its data initialized using by ID method Hibernate API. In both cases, null is returned if no matching database row was found. It is possible to return in a Java 8 optional as well. Here the obtaining an optional entity entity reference with its data initialized using by ID Hibernate API. Now we are considering obtain multiple entities by their identifiers. Loading multiple entities using by multiple IDs. If you want to load multiple entities by providing their identifiers, calling the entity manager dot hash find method multiple times is not only inconvenient but also inefficient. While the Jakarta persistent standard does not support retrieving multiple entities at once other than running JPQL or criteria API query, Hibernate offers this functionality via the by multiple IDs method of the Hibernate session. The by multiple IDs method returns multi-identifier load access, which you can use to customize the multi-load request. The multi-identifier load access interface provides several methods which you can use to change the behavior of the multi-load call. So enable order return boolean enabled, enable session check boolean enabled, enable return of deleted entities boolean enabled, with lock options, with cache mode, with batch size int batch size, with root graph t graph. Now assuming we have 3% entities in the database, we can load all of them with a single call as illustrated by this example. Here the method multi multi-identifier load access T by multiple IDs class T entity class create a multi-identifier load access instance to retrieve multiple entities at once as specified by the primary key values, and this is in the interface session which is in the package org.hibernate. Notice that one SQL select statement executed since the second call uses enable session check method of the multi-identifier load access to instruct Hibernate to skip entities that are already loaded in the current persistent context. If the entities are not available in the current persistent context, but they could be loaded from second level cache, you can use with cache mode cache mode method of the multi-identifier load access object. In the example here, we first make sure that we clear the second level cache. In this example, we first make sure that we clear the second level cache to demonstrate that multi-load query will put the returning entities into second level cache. After executing first by multiple IDs call, Hibernate is going to fetch the requested entities and illustrated by get second level cache put count method call. 3 entities were indeed added to the shared cache. Afterward, when executing the second by multiple IDs call for the same entities in a new Hibernate session, we get the cache mode dot normal second level cache mode, so that entities are going to be returned from second level cache. The get second level cache hit count statistics method return 3 this time, since the 3 entities were loaded from second level cache, and as illustrated by SQL statement interceptor dot get SQL queries. No multi-load select statement was executed this time. Um, Now we are considering obtain an entity by natural ID. Load entity by natural ID. Annotation type natural ID specifies that a field or property of an entity class is part of natural ID of the entity. This annotation is very useful when the primary key of an entity class is surrogated key, that is a system generated synthetic identifier with no domain model semantics. There should be always be some other field or combination of fields which uniquely identifies an instance of an entity, instance of the entity from the point of view of the user of the system. This is the natural ID of the entity. This is in the package org.hibernate.annotations. In addition to allowing to load the entity by its identifier, Hibernate allows application to load entities by the declared natural identifier. This is a natural ID mapping here. You can also opt to fetch an entity or just retrieve a reference to it when using natural identifier loading methods. Here get entry reference by simple natural ID, load entity by natural ID, we can also use Java 8 optional to load entity by its natural ID. Hibernate offers a uh, consistent API for accessing persistent data by identifier or by natural ID. Each of these define the same two data access methods. Get referenced should be used in cases where the identifier is assumed to exist, where non-existence would be an actual error. There should never be used to test existence. That is because this method will prefer to create and return a proxy of if the data is not already associated with the session rather than it hit the database. The quintessential use case for using this method is to create foreign key based on associations. Load will return the persistent data associated with the given identifier value or null if that identifier does not exist. Each of these methods defines an overloading variant accepting org.hibernate.lock options argument. Locking is local lock options argument. Getters and setters are omitted for brevity. Now we are considering at-where in filtering entities and associations. Here at-where mapping usage. Sometimes you want to filter out entities or collections using custom SQL criteria. This can be achieved using where annotation which can be applied to entities and collections. Annotation type where specifies a restriction written in native SQL to add to generated SQL when querying an entity collection. If the database contains the following entities, here the persistent and fetching entities with where mapping, getters and setters omitted for brevity. Getters and setters omitted for brevity. When executing an account entity query, Hibernate is going to filter out all the records that are not active. Now we are considering modifying managed and persistent or persistent state. Here modifying managed state with the Hibernate API. Entities here the method void flush force this session to flush must be called at end of a unit of work before transaction is committed. Depending on the current flush mode, the session might automatically flush when entity transaction.commit method is called, and it is not necessary to call this method directly. This is in the interface session and in the package org.hibernate. Entities in managed persistent state may be manipulated by the application, and any changes will be automatically detected and persisted when persistence context is flushed, where there is no need to call a particular method to make your modification persistent. Here modifying managed state with Jakarta persistence. Here modifying managed state with Hibernate API. By default, when you modify an entity, all columns but the identifier are being set during update. Now we are considering refresh entity state. Refreshing entity state with Hibernate, here Hibernate API. Method void refresh object reread the state of the given managed instance associated with this session from the underlying database. This may be useful when a database trigger alters the object state upon insert and update. After executing any SQL update or delete statement, after executing a native SQL statement, after inserting a blob or club. This is in the interface session and which is in the package org.hibernate. You can load an entity instance and its collections at any time. Refreshing entity state with Jakarta persistence here. Refreshing entity state with Hibernate API is here. One case where it is useful when it is known that the database state has changed since the data was read. Refreshing allows the current database state to be pulled into the entity instance and the persistence context. Another case where this might be useful is when database triggers are used to initialize some of the properties of the entity. Only the entity instance and its value type collections are refreshed unless you specify refresh as a cascade style of any associations. However, please note that Hibernate has the capability to handle this automatically through its notion of generated properties. Traditionally, Hibernate allowed at detached entities to be refreshed. Unfortunately, Jakarta persistence prohibit this practice and specifies that illegal argument exception should be thrown instant. For this reason, when bootstrapping the Hibernate session factory using the native API, the legacy detached entity refresh behavior is going to be preserved. On the other hand, when bootstrapping the Hibernate through Jakarta persistence, entity manager factory building process detached entities are not allowed to be refreshed by default. However, this default behavior can be overridden through Hibernate allow refresh detached entity configuration property. If this property is explicitly set to true, then you can refresh detached entities even when using Jakarta persistence bootstraps mechanism, therefore bypassing the Jakarta persistence specification restriction. Now we are considering working with considering reattaching detached data in working with detached data. Here reattaching a detached entity using lock. The method void lock object lock options obtaining a lock on the given manage instance associated with this session using the given lock options. This is in the interface session and it is in the package org.hibernate. Reattachment is the process of taking incoming entity instance that is in the detached state and associating with it with the current persistence context. Jakarta persistence does not support reattaching detached data. This is only available through Hibernate org.hibernate.session. Here reattaching detached entity using lock. Here reattaching detached entity using save or update. The method name update is a bit misleading here. It does not mean that SQL update is immediately performed. It does however mean that SQL update will be performed when the persistent context is flushed, since Hibernate does not know previous state against which to compare for changes. If the entity is mapped with select before update, Hibernate will pull the current state from the database and see if update is needed. The provided entity is detach update and save update operate exactly the same. Here it's not shown here, but you can see the merge is there. Clear session on the person entity becomes detached. Clear session on the person entity becomes detached. Now we are considering checking persistence state and verify manage state with Hibernate API here. An application can verify the state of entities and collections in relation to the persistent context. Here verify manage state with Jakarta. Verify manage state with Jakarta persistence. Here verify manage state with Hibernate API. Here Now we are considering evicting entities. Here you can see evicting an entity from the Hibernate session. Here the method void evict object remove this instance from the session cache. Changes to the instance will not be synchronized with the database. This operation cascades to associated instances if the association is mapped with cascade type dot detached. This is in the interface session and which is in the package org.hibernate. When the flush method is called, the state of the entity is synchronized with the database. If you do not want this synchronization to occur, or if you are processing a huge number of objects and need to manage memory efficiently, the evict method can be used to remove the object and its collections from the first level cache. Here you can see the detach entity from entity manager. Here you can see evicting an entity from Hibernate session. To detach all entities from the current persistence context, both the entity manager and the Hibernate session defines a clear method. Here clearing the persistence context. To verify if an entity instance is currently attached to the running persistence context, both entity manager and the Hibernate session define contains object entity method. Here verifying if an entity is contained in a persistent context. Now we are considering cascading entity state transitions. The following example will explain some of the aforementioned cascade operations using the following entities. Public static final cascade type all includes all types listed here and equivalent to cascade type all. This is in the enum cascade type, which is in the package org.hibernate.annotations. Jakarta persistence allows you to propagate the state transition from a parent entity to child. For this purpose, Jakarta persistence those cascade type define various cascade types. All means cascade all entry state transitions, and persist merge, persist cascade entity persistence operation, merge, remove, refresh, detach. Additionally, the cascade type all will propagate any Hibernate specific operations, which is defined by the org.hibernate.annotation.cascade type enum. And they are save underscore update, replicate, lock. The following example will explain some of the aforementioned cascade operations using following entities here. Here as an example, cascade type dot persist. The cascade type dot persist allows us to persist a child entity along with parent one. So here the cascade type persist example here. Even if just person parent entity was persisted, Hibernate has managed to cascade the persistent operation to the associated phone child entity as well. Now we are considering exception handling. The here constraint violation exception indicates some form of integrity constraint violation. This is the class constraint violation exception. A JDBC exception indicating that the request's DML operation resulted in violation of defining integrity constraints. This is in the package of hibernate.exception. As an example, we can consider class persistent object exception thrown when the user passes a persistent instance to a session method that expects a transient instant. This class is in org.hibernate package. As an error example, we can consider this detach entity pass to the persist com.bwt.spindle.model.plot. Now this is the end of my presentation. Thank you very much for watching it.